testing mobile net neutrality. First of all, what is net neutrality? Net neutrality, all bits are created equal. It's not just a good idea, it ought to be the law. Well, in the Netherlands, it is the law. We have a law in the Netherlands that says ISPs have to be net neutral, and all bits have to be created and managed equally. But then, how do you explain in internet net neutrality? There's a word cloud that has all kinds of words that are supposedly explaining net neutrality. I still think it's a very hard concept to explain and to say what it is, and it's even harder to test it. This is what I'm about to show. An easy thing to see if it's not working is, well, it's not working. It's supposed to show a little kitty here. The internet day is clogged. So there were some reports that the internet was clogged, that there was some blocking going on. And then we started a working group at the Internet Society in the Netherlands with a working group. So a working group was started, and then we made an application, an app for the Android and the iPhone, and then people could start testing on their own mobile network. You just pushed the button, and then started sending out some packets and making sure that they got to the other side. And then with that app, we found some further evidence that there was stuff not getting to the other side. So you say there's some parts of it that's being blocked, and they say, isn't that against net neutrality? So the journalists got involved. This was published on Webwereld. They made some allegations saying we are seeing evidence that KPN is blocking, or that Simyo is blocking VoIP traffic, and this is against net neutrality, so they shouldn't be doing it. And then KPN's reaction was initially, no, we don't. So then I thought, well, so the app is testing it, but I don't really know exactly what the app is doing. So let's test it in a more controlled environment and use internet tethering on my phone, and I'll do some hacking, which you're apparently doing with a mask, and you're holding your computer in one hand. But then, so testing net neutrality. I wrote a very simple client saying, so this is a client, open a socket, this is the message to server.example.com at port 5060, which is the port that's being blocked. I mean, that's the way you test blockage of a port, right? At the other end, you bind the server to the same port, and then you listen on the port, and then you print a message. Okay, done. I tested on Wi-Fi to make sure that it works, and I also tested to make sure that I'm not seeing some coverage issues, that my data connection is not completely working or something else. So I also tested on port 5061. So I sent a packet on port 5061. This is from a Wi-Fi network here, actually. So I tested here on the Wi-Fi network, and the Wi-Fi network is not blocking VoIP traffic because the packet just goes through. I see this is the message, this is the message. Then I tested on Simyo network, and all I see on the other side is port 5061. This is the message. Port 5060 doesn't show up. Okay. So we had another meeting with the press and said, well, we have very strong evidence. Well, we basically know that if I send a packet out on port 5060, it's not getting to the other side. And then the webwereld picked this up, and they said, well, so I had to corroborate I could corroborate the story that the net neutrality, that there was a problem on port 5060 and that packets were not getting to the other side. And KPN again said that no, we don't. Yes. No. So this is a simplified version. I tried this on several different locations with several different phones on several different carriers. So this and repeatedly. So this was really an issue with port 5060. So yeah, I really made sure, and I tested with a different phone to make sure that the phone itself was not blocking it, and etc. It turns out that so port 5060 is being used by VoIP, and if you look up VoIP, then you see it's not showing. Then you see if you look up VoIP in images, then you get somebody with an 80s hairstyle with a very big phone and a very old computer, and then that's VoIP. How VoIP works. So you have PCs, you have telephones with a VoIP adapter. Everything is hooked up to the cable modem, sends out to the internet, and then either to a VoIP phone or to a PC. Okay, that seems to be simple. But then some problem shows up, and that says we're running out of IP addresses. Obligatory shard, it's not showing very well. We're running out of IP addresses. There's no IP addresses left. So, what do we have? We have NAT. And NAT is evil. But NAT, in order to do NAT traversal, you have to do some tricks. So in the KPN network, if you call from your phone through the internet, through the LAN, you have a link local, or you have a private address, and it's being forwarded to some kind of Juniper system, and it does an application layer gateway. So it's an application layer gateway, and it does a translation, and it changes the packet a little bit, and it sends it out on the other side. This has a private address as well, but for the public internet, it works the same way. So it does a translation, and it goes out to the other end. I actually found this out here at home when we talked to the KPN engineers, because they were also here. We got together and we started looking at what's going on. Why are we seeing this kind of things? And why is it that the UDP packets are not coming out at the other end? So since we're both here, we sat down together and we tried to debug the issue. In the end, we found out that if you do a VoIP session, then it does get through. The problem is the application layer gateway looks at the packet and sees that this is a SIP packet, and for SIP packets it knows, okay, it identifies SIP packets by being on port 5060, and it inserts an extra header, the via header, saying if you want to reply back to this IP address, and then I'll forward it further on using the identifier that's in the branch here. So it identifies the flow based on the branch ID here, and this is the header that's being used, and you should also say this is the from, and etc. So the application layer gateway does this for SIP traffic that comes in on port 5060, but random UDP packets on port 5060 are not SIP packets. And the application layer gateway said, oh, this is not SIP. I don't know what to do with SIP, so let's drop it. And it basically drops it. So this is why the UDP packet that you send out on port 5060 doesn't get to the other side because it's not being recognized as really SIP. But if you really do SIP, then it does go through to the other side. The only thing right now is that we still have to figure out what it is exactly that's going wrong with some of the clients, because we are seeing that some of the SIP clients, they do get the packets through to the other side with the extra via header, but they're not able to set up a connection. And testing it here has been a little bit hard, and we have to do some further testing and experimenting in a more controlled environment with some more resources that we can actually see what's going on. And then we can conclusively say that I mean, if we run those experiments, then we can really say what's going on and why it has been that the VoIP clients have not been working correctly. The conclusions: net neutrality is really hard. It's a hard concept to explain why it's important, to explain why it is that we need it, to explain what it is, and it's also hard to implement and criticize. This also reaffirms the point that NAT is evil, and it really should die. It also says that SIP is a mess. Why I still don't completely understand why it is that SIP needs to have an extra bits added to make it work through NAT. I mean, I can understand that if you want to call somebody at the other end, then yes. But if you're calling out, then it shouldn't be necessary. Apparently, that's not possible. And I also want to say that the CISO team, the security team at KPN, working with them here at OHM has been really awesome. They have been very open about the whole issue. They've been working with me to figure out what it is that's going on. I should have contacted them much earlier, and I think that if we got together earlier before we went to the press, or at least before this got out in the press, then it wouldn't have been such a confusing issue on the web vitals, because in essence we're both right. I mean, the UDP packet that I sent out didn't come out at the other end, but no, they're not blocking VoIP. So.
By essentially doing the same specifically for SIP, they are blocking other traffic on that board. Yeah.
Well, yes, but then again, yes, but there are many other ports still available to do your thing. And you don't really want to do some kind of other service on port 80 either.
But the real evil is carrier-grade NAT, which you cannot control.
No.
That's causing the problem. Carrier-grade NAT, your provider doing NAT for you. That's what's happening here. And that's the real evil in this case.
Yeah.
You have to do fix up for VoIP.
Then you can say that the big problem is that we ran out of addresses and that we still haven't fixed that.
The fix is available.
Yeah.
But nobody applies it.
Yes.
So at the end, the problem was not that the carrier went for a policy that make this no. So at the end, it was not like a policy from the carrier that wanted to block like a voice feed.
No.
Okay, so
No, this is not a policy issue. No. No.
an issue.
There's not. So there's a little bit of an issue because some of the SIP clients, they don't work with this modification, and we have to figure out whether this is because the modification is not correct, or whether the clients are not really listening to the traffic correctly. and the SIP standard is really difficult.
That's an interoperability problem.
It could be an interoperability. Yeah. So yes, it is an interoperability problem.
One of the slides assumes too much about how all the slides work.
Yeah. Yeah.
So what should we do about it?
What should we do about it?
IP46.
We should move to IPv6 as soon as possible, because then the problem with NAT goes away. Sorry? Yes. Like I said, I've been working with KPN here at home to figure out what the issue was. And we have already planned follow-up meetings to do further testing and really figure out where the problem is and whether this is a problem with the implementation of the netting and the traffic modification that they're doing, or that this is a problem with the SIP clients.
Yeah, but basically this is the current status of the configuration of the network. They are going to improve the IPv6 impacting the customer, in the final customer, or this is just let's figure out.
That's I don't know what KPN does. I mean, I don't work for KPN. He works for KPN.
Deploy IPv6 in the mobile network. I don't know when they're going to deploy IPv6 in the mobile network. But the problem is we're out of IP4 addresses, and as long as everybody keeps buying smartphones, we'll keep running out. But no, I don't know. But it needs to be done. That's pretty clear. I mean, it needs to happen. But before you can change the whole infrastructure, that's quite a major operation.
Please be vocal internally. That's all this PR mess could have been solved if to IPv6. So
How did you initially test with the app? What kind of packets did you send out? Did you just send UDP packets on each port and test that? Or did you try sending types of packets? Because I think that the greater danger is not blocking a port, which is easily detected, but deep packet inspection.
Yeah. So one of the things is that I don't completely know what the implementation of the app is. I didn't build the app myself. Somebody else in the group did that. And one of the things that we wanted, my impression is that they probably built a test in the same way that I did. Just open a socket, send out a packet, and compare at the other end. And now we've learned that this is not the best way to test this kind of issue.
actually it is. Because I appreciate KPN trying to make voice work, but I don't want a network provider applying any application gateway in the network between me and my server. If I want to run HTTP tunneled over UDP over port 5060, that's my right to do on the internet.
Yeah.
Even if it's a total bad idea, I agree. But a provider shouldn't block that. It doesn't really matter if it's malintent, which it clearly isn't, or just applying a hack. And we shouldn't apply hacks in these kind of things.
Yeah, I think that, I mean, in the end result, the implementation in the application layer gateway is not optimal.
The fact that it's there is not optimal.
Well, so the fact that it's there isn't optimal, but like I said, SIP is a mess.
True.
So apparently that's the standard, and we have to live with it. But then again, the implementation that you automatically draw packets that are not SIP, that's not really like an optimal solution, and this is something that we may have to look at. Yeah.
Jeroen, isn't this also partly the problem of what you write down in net neutrality in the law? Because the interpretation that every TCP or UDP socket should go unrestricted without application gateways through the network is not easily done in the law, because they make net neutrality a much fuzzier ID. Because you say, well, we don't interfere with the application running over the flow.
Yeah.
And effectively, they only allow now SIP sessions over port 5060, which is a very different interpretation of what net neutrality effectively is.
First of all, I am not a lawyer, so I don't know what the correct interpretation of the net neutrality law
There
should
aren't
be.
concepts like port numbers in the law.
No.
That's
No.
the point.
Yeah. uh, One of the things is with net neutrality is that we the issue is again SIP is a mess and it should be working properly across NAT. NAT is evil and we have to live with it. We have to live with SIP. Yeah, I mean, in the end, KPN has to work with the things that they have. They try to provide a service, and in this case, I think the intention is to make SIP actually work across port 5060, and to help clients do that. Then, yeah, but then the end result is that some of the clients aren't implemented correctly, or that there's something wrong with the way that this is done, and then it doesn't work.
In my opinion, it's a choice between two evils. I can
Yeah.
say, okay, I just leave the port open and you can do with it what you want, but SIP won't work. And then
Yeah.
people start complaining, I can do VoIP from your network.
Yeah.
So I have to put in an ALG. And well, the majority that wants to use port 5060 wants to do SIP. So that's why the ALG is there. It's not a big principle or something. It's just a practical choice. But I agree. If you look at it, you should want to have each port open.
So, and again, it boils down to the issue that net neutrality is really hard.
And second, that is evil.
Yeah, net is evil, and SIP is a mess. All right. I think that's... Oh, then another question? Yeah.
If you look at this, what we now have effectively seen is the problems you get with network address translations and some kind of blocking function in the internet. What is going to happen if you introduce laws that require even more of this kind of functionality being introduced in routers or in networks? Do we get multiple problems, and will this become a major area of research and technology and fixing?
I think that spells a job security.
A job creator idea. Yeah.
Yeah, yeah.
I don't know if you know about a project called Choke Point Project.
Yeah.
Okay, so they have been like doing measurements and also RIPE Atlas.
Yeah.
They are doing like all these kind of measurements. I don't know if there's a website in which you can know if a provider provides like good VoIP, like I mean something that could be like a measurement of what your provider is doing, if it's doing a good job or not in this case.
Yeah.
So that would be great to have like a website for mobile phone companies or something like that.
And I think that this is also something that we want to create, and this was the initial intention to do with the app, that you quickly see. So you press the button, and then you see the score for your provider. But now we learned that this is a hard issue. And that it takes some more work and some more research in order to make sure that the score that you get for your provider is actually the right one. So the journalists got involved. This was published on Webwereld. They made some allegations saying we are seeing evidence that KPN is blocking, or that Simyo is blocking VoIP traffic, and this is against net neutrality, so they shouldn't be doing it. And then KPN's reaction was initially, no, we don't. So then I thought, well, so the app is testing it, but I don't really know exactly what the app is doing. So let's test it in a more controlled environment and use internet tethering on my phone. And I've been going on. And then we started a working group at the Internet Society in the Netherlands with a working group. So a working group was started, and then we made an application, an app for the Android and the iPhone, and then people could start testing on their own mobile network. You just pushed the button and then started sending out some packets and making sure that they got to the other side. And then with that app, we found some further evidence that there was stuff not getting to the other side. So you say there's some parts of it that's being blocked, and they say, isn't that against net neutrality? Testing mobile net neutrality. First of all, what is net neutrality? Net neutrality, all bits are created equal. It's not just a good idea, it ought to be the law. Well, in the Netherlands, it is the law. We have a law in the Netherlands that says ISPs have to be net neutral, and all bits have to be created and managed equally. But then, how do you explain in internet net neutrality? They do some hacking, which you're apparently doing with a mask, and you're holding your computer in one hand. But then, so testing net neutrality. I wrote a very simple client saying, so this is a client, open a socket, this is the message to server.example.com at port 5060, which is the port that's being blocked. I mean, that's the way you test blockage of a port, right? At the other end, you bind the server to the same port, and then you listen on the port, and then you print a message. Okay, done. I tested on Wi-Fi. There's a word cloud that has all kinds of words that are supposedly explaining net neutrality. I still think it's a very hard concept to explain and to say what it is, and it's even harder to test it. This is what I'm about to show. An easy thing to see if it's not working is, well, it's not working. It's supposed to show a little kitty here. The internet day is clogged. So there were some reports that the internet was clogged, that there were some blockages.